this video, we're going to take a look at how to evaluate a log. Now, a logarithm is a function that is an inverse to an exponent. So we discussed that what you're searching for on a log is you're searching for the exponent, or how many times you would raise a number to get another number. So when we're dealing with these, we're going to be answering this question: what power do I raise the base to in order to get this answer? For instance, you may have a problem like this, where it's log and it's base 2 of 32. Now, you can look at it this way and answer this question, or another way to look at it that might be helpful for you is if we switch this into an exponential equation. Now, to switch into an exponential equation, we can just let this equal some letter. We'll call it x. And then we do a little thing that I call looping it, because which I got from a colleague a long time ago, and she explained that you're just making a loop around the equal sign. That's why it's called looping it. You always start at the base, whether it's an exponential equation or whether it's a log equation, and our base here is 2. And then we make a circle around the equal sign, or we loop ourselves around the equal sign. So 2 to the exponent of x equals 32, and that switches this from log form into exponential form. And then you can see that we truly are looking for the power that I would raise 2 to in order to get to 32. Now, these are problems that you might have to do on a non-calculator version of a test. So you'll have to be able to tell what you would raise 2 to get 32. Now, it might sound old-fashioned, but you can actually do this very easily by counting on your fingers. So when you have 2 to the first power, which 2 to the first power would be this holding your one finger up because your exponent is 1. 2 to the first power is just 2. And then 2 times another 2, which gives you 2 fingers here, is 4. And then if you take that 4 times another 2, which is going to give you 3 2s, so we have 3 fingers here, that gives you 8. And 8 times another 2 gives you 16. You now have 4 fingers, so that's an exponent of 4. And then 16 times another 2 gives you 32. We now have 5 fingers up, so now we know that this 32 is the same thing as 2 to the 5th. And once we get so that the bases are the same, our exponents will be equal. So we know that the x has to be 5, which means if we're just evaluating this expression up here, and we ask ourselves, what would I raise 2 to in order to get 32? The answer would be 5. And you can see that that's true by looping it. 2 to the 5th power is indeed 32. So you can see that it works with that. So now let's take a look at another one doing that same thing. So let's go ahead and take a look at this problem. This is log base 5 instead of log base 2. And so it's log base 5 of 125. So you're asking yourself, what power would I raise 5 to in order to get 125? Another way to look at this would be to say, well, let's let it be x. 5 to the x is 125. So we need to see what power we would raise 5 to get 125. Well, let's count on our fingers. 5 to the first is just 5. 5 times 5 is 25, and that's 2 fingers, so that's an exponent of 2. 25 times another 5 is 125, and I'm right here at the 3 fingers. So I know that 5 to the third power is the 125. So that means the exponent we want is 3, which means when I'm evaluating log base 5 of 125, the answer is 3. Because if I take 5 to the third power, I get 125, and I'm looking for the power that I would raise 5 to get that. So let's go ahead and try one more here. This is log base 3. So now I'm going to take 3 and raise it 2 powers until I get to 81. So I need to find out how many fingers I need, or what exponent I need, in order to get to 81 when I'm multiplying by 3. So let's go ahead and start with 3 to the first. That's 1 finger, and so that's 3. 3 times 3 is 9, and that's 2 fingers. 9 times 1 more 3 is 27, and that's 3 fingers. And 27 times 1 more finger, or 1 more 3, is 81. And I'm at the 4 fingers here. So that means that my answer is 4. And if we want to check it, 3 to the 4th power is 81. And so we know that that is correct. Let's try one more before we move on. How about this one? This is log base 7. So now I'm raising 7 to an exponent, and I need 49. This one's actually going to be a little bit easier. 7 to the first is 7, and 7 times 7 is 49. I'm only at the 2 fingers. So that means the exponent I raised 7 to get 49 is 2. And if you want to check it, 7 to the 2nd power is 49, and that is a true statement, so we know that our answer is correct. So now let's take a look at how we can apply this to a couple of situations. If you have your supplement, you might want to get it out. These are some problems in there. Let's say that you are actually trying to find a function to go with this graph that we have right here. So this graph that we have right here, you're trying to find a function that goes with it. Notice there's a couple nice points. We have the point 1, 0, and we have the point 9, 2. 1, 0 in terms of logs is not going to get you very much, but this 9, 2 might help you out. We're plugging a 9 in, which means the x here and here would be a 9, and the answer is 2, which means this is 2. That's actually enough to get you what you need to find out the base on this log. So notice that in this example, we plug in 9, we get 2 back out. So that means log base b of 9 is 2. In order to solve this, you can go ahead and loop it. B to the 2nd power is 9. And that means b squared is 9. So if you square root both sides, you end up with b equals 3. Now, normally we would square root both sides and do a positive and negative, but we don't normally have a base that's negative, so you only take the positive on that. So let's go ahead and see if we can apply this to a couple problems that might be not quite so easily seen as this one. So we have a couple situations where we have tables and we also have graphs. So let's look at the graph first. Notice that on the graph we have this point 1, 0. That's not going to get us anything. But way out here we have this point that's 25, 4. That 25, 4 is what's going to help us get our answer. So if we're plugging in here, the x here is going to be 25, and the f of x is 4, because that's what we got back out. And notice there's an a as our base on this one, so that's fine. We'll do log base a of 25 equals 4. So now let's go ahead and loop it, and that will help us get the a out of that base so that we can actually find out what a is. So a to the 4th equals 25. Now, to solve this, we can do a fourth root or raise it to the 1/4 power. I'm going to actually raise it to the 1/4 power because that's going to be a little bit clearer for why we do what we do when we simplify. So I'm going to raise it to the 1/4 power because that's the opposite of raising to the fourth. And that's going to leave an A on this side. Now, when I write the other side, I want to be able to simplify things, and I notice that 25 is 5 squared. So why don't I switch it to 5 squared, and we'll see that we actually get a much simpler answer than if we were to just write the fourth root of 25. So I'm going to do 5 squared instead of 25, and I'm still raised to the 1/4. And when you have a power to a power, you multiply them. So we can multiply the 2 and the 1/4. And that gets you 5 to the 2/4, which is the same thing as 5 to the 1/2. If you remember, a 1/2 exponent is the same thing as square root of 5. So A is really the square root of 5. That means the function for this graph is f of x equals log base square root of 5 of x. So that helps us with one that's a little bit tricky. Now, what about these tables? On the tables, notice that we do have the point 1, 0 on both of them. That one's not going to get us much. And I would try to find the point that gives you the easiest thing to solve. So all the decimals and square roots and stuff, those might not be points you want to actually choose. So on number 2, the point that I would actually want to use is going to be that 402, because that's the nicest looking number out of all the ones in the table. It doesn't matter which one you choose. I just choose one that's a little easier to deal with. So I'm going to plug in the 400 where the x is, and the f of x is going to become a 2. So I have log base A of 400 equals 2. If we now go ahead and loop it, we'll be able to find out what our base on our log is. So A to the second equals 400. So now to solve that, we can just square root both sides. And A ends up being 20. So the function for this one is f of x equals log base 20 of x. Now how about this last one here? The last one, I have several points that are pretty easy. All of the ones to the right of the point 1, 0 would be nice. I'm going to stick with this 3, 2, because those are the smallest numbers. So I'm going to replace the x with 3 and the f of x with 2. So I'm going to get log base A of 3 equals 2. Now let's go ahead and loop this. A to the second power equals 3. And now we can go ahead and square root both sides, and A ends up being square root of 3. That makes the function for number 3, f of x equals log base square root of 3 of x.